So the other thing we can use the tangent ratio for is to help us find unknown sides in right angle triangles. And I'm going to show you how to find two different strategies for finding sides in right angle triangles. One when we're looking for the opposite side and one when we're looking for the adjacent side. So again, Pythagorean theorem is a strategy we've used in the past to do this. If we know two sides of the right angle triangle, then we know that the sum of the squares off of those two sides would be equal to the sum of the square of the hypotenuse. So if we know two sides, we can use Pythagorean theorem. However, if you look at this triangle right here, we only know one side in this right angle triangle. So we can't use Pythagorean theorem to solve this, because in order to use Pythagorean theorem, we need two. However, we do have some additional information this time, knowing that this angle right here is 40 degrees. So what are we going to do? We know that the tangent of theta is equal to opposite over adjacent. So I'm going to start off by writing out that formula. So what I'm going to do to be able to use this formula is I'm going to go back to my triangle and I'm going to label everything I can. So first of all, I know that this is 40 degrees. I'm going to choose this to be the angle that I'm going to work with. So I'm going to circle it to remind myself that is the angle I'm going to be referencing. I'm now going to label the triangle with reference to that angle. So I know that the side across from my right angle is called the hypotenuse. I'm going to call that H. If I look across from the angle that I'm working with, angle 40 degrees, I know that this side over here is going to be the opposite side. And then the side left over is always my adjacent side. It's right beside the angle that you're working with. So the side that is my adjacent in this case is going to be 14.2 inches. Okay? So going back to my formula, I'm going to sub in everything I know. So I know that the tan of my angle, and in this case, my angle is 40 degrees. So the tan of 40 is equal to my opposite side, which is my unknown, that's x, divided by my adjacent side, which is 14.2. So tan of 40 degrees is equal to x over 14.2. So I know that for every right angle triangle that has an angle of 40 degrees, there will be a ratio that is equal to a certain number, and I can use that ratio and that number to help me find x. So to figure out what that certain number is, I'm going to look in my tan ratio chart. So I'm going to look over at 40 degrees. So there's my 40. So there's my 40. That ratio for all right angle triangles, no matter how big or small they are, will be 0.839. So tan of 40 using my chart is going to be replaced by the ratio 0.839. So that means that 0.839 is equal to x over 14.2. So now what we need to do is we need to isolate for x. So we can do a couple different strategies for this. So one strategy comes from when we were doing our equation solving. If you had an x and you had a number that was dividing it, so if we have x divided by 14.2, if I want to get rid of that 14.2 to get the x by itself, I'm simply going to multiply both sides by 14.2. If I do that, I get approximately 11.9. So that's one way to do it. Another strategy is to use cross multiplication. And I'm showing you this strategy because when we do the adjacent side in the next example, this is the strategy that I usually use. So what I do is I take this ratio and I rewrite both sides as fractions. So 0.839 becomes 0.839 divided by 1 or over 1. And we know that's equal to x over 14.2. So in order to get x by itself, I'm going to cross multiply to get rid of the fractions. So on one side, I've got 1 times x, which is simply x. And on the other side, I have 14.2 times 0.839, which is approximately 11.9. So you can see how through cross multiplication, you can get the x by itself and figure out that it is equal to approximately 11.9. Okay? So to recap, when we're trying to find the opposite side, you circle the angle you're working with, you label the sides of the triangle with reference to that angle, the opposite, the hypotenuse, and the adjacent. We write out our formula. We sub in the values of what we know, including the angle and the adjacent side. We use our chart to figure out what value tan 40 is actually equal to in decimal form. And then we use algebra, whether it's cross multiplication or some of those strategies we use for solving equations, to figure out what x is equal to when we get x by itself. Okay? In the second example, it's just a little bit trickier because of where the unknown side ends up going. So I want to do this one with you as well. It's similar, but there's a little an extra little step we have to do at the end. So again, I want to find the adjacent side. I only know one side of my triangle. I don't know two, so I can't use Pythagorean theorem. However, I do know an angle, and once again, this angle is 40 degrees. So I'm going to circle the angle I'm working with. I'm going to label the sides with reference to that angle. So across from it, I have my opposite. Across from my right angle is my hypotenuse, and beside it, I have my adjacent. So tan theta is equal to opposite over adjacent, as usual. I'm going to plug in my values. Theta is equal to 40 degrees, so I have a tan of 40 degrees. And I know that's equal to my opposite side, which is 1.7 centimeters. So I put in 1.7 divided by my adjacent. That is the side I'm trying to find. My unknown is y, so I'll just call the adjacent y. Tan 40 equals 1.7 over y. I want to solve for y. So I'm going to start off turning this into a number. The tan of 40, as we saw in the first example, if I go to my chart, tan of 40 degrees is equal to 0.839. So 0.839 is replacing my tan of 40. That's still equal to 1.7 over y. And in this case, the strategies that we use for equation solving are a little bit trickier because this time the y is at the bottom of the fraction. And this is why I like to use cross multiplication, because cross multiplication will help me get that y back up on top. So what I'm going to do is I'm going to take this fraction and I'm going to rewrite my 0.839 as 0.839 divided by 1 equal to 1.7 divided by y. And then I'm going to cross multiply. So I'm going to take my 0.839 times y on one side, and then 1 times 1.7 on my other. So I get 0.839y equals 1.7. Well, now I want to get the y by itself, which means I need to get rid of my 0.839 in front of it. It's being multiplied, so to get rid of multiplication, I'm going to divide. I'm going to divide both sides by 0.839. 1.7 divided by 0.839 is equal to approximately 2.026. So we have to do that extra step because the y isn't isolated when I cross multiply, to divide both sides by that number in front of the y. And I get my side, my adjacent side, to be equal to approximately 2.026. So again, we find the angle we're working with, we label the triangle, we write out our formula, we sub in our values, we use our chart to figure out our tan ratio value, and then we use the strategy of cross multiplication in order to isolate for the side that we're looking for and find the unknown side of the triangle.